family relations.
Okay, welcome back. Can everybody hear me all right? Sounds great. Today we'll be talking about web scraping and about working with APIs. We'll start off with web scraping because that's kind of like what you will need for your homework. And so I want to make sure that we get through that. And then basically, both of them are complementary techniques to collect data. So far, we've always kind of assumed that the data is nicely available somewhere, downloadable, and we can just like put it in a file. Today, we'll be covering like one way of getting data from the web, especially when it's not just like made for like as a downloadable data set. We'll be also looking at some other ways of like acquiring data, especially like for databases, though databases usually are only available if you're like part of an organization. So there's like very rarely is like a full-on database completely available to the public. Usually like a database is made available through an API for a program. But if it's not made available for a program, but just through a website, we can still get the data out of it by using web scraping tools. And so before I start with this, I just want to do this quick poll here. Say yes to this if you've looked at HTML source code really like in a structured way, if you've written your own HTML code, if you like have taken a class on web analysis. Okay, we have about 2/3 who have not worked with HTML. So I'll share the results here. So yeah, the scraping is actually not all that hard, but you have to understand a little bit about HTML. And so that's why it can be a little bit tricky to get into it if you haven't if you haven't really worked with HTML before. And so I see that like more than 2/3 of this crowd here haven't done that. So I'll give like a quick introduction into HTML and the DOM and into the browser, because we'll need that to do scraping. OK, so what is HTML? HTML is the hypertext markup language. So traditionally, like back in the 90s, you used to create a website by writing HTML directly. Nowadays, it's a little bit more complicated than that. HTML is actually like sometimes you write HTML, but most of the time you write some JavaScript. You get something from out of a database and then generate what looks like HTML into the DOM. The DOM is the document object model, which is kind of like this tree where this data is stored. HTML now isn't just like a document language anymore. It is really like a programming language almost combined with JavaScript and CSS for the web. So we build very complex applications with HTML. And we have video, we have graphics, we do visualization, we have audio, and so on. So it's really like a new operating system, and it's easier to think for you like HTML is whatever a web browser knows how to interpret. And so HTML is at its very core is made up of elements. So here we would have like an element. In this case, this would be a strong element. And so this kind of like we have tags, element tags, an opening and a closing tag, and this tag applies to everything that's between those two tags. So this would be like your most simple HTML element indicating that this should be bold or strong text. But typically, like you can also nest this. So for example, you can do something like strong and then have a U, which is an underlined. And so this would be an underlined and strong text. And then you can add hyperlinks. And hyperlinks are just like links to other pages or within the page. And you could add a hyperlink with like this syntax here. You would have an A element, an A tag, and then you would have an attribute. The attribute here would be the URL, and this is like the href attribute, and we specify the URL. And then here, this is the part that will then be, this is the part that then will be underlined, for example, and that this is the part of the text that you will be able to click. So A, traditionally, this is like used to be an anchor, but now it's just like basically think of A as just like the link thing. And the href attribute is the reference that we often want to extract. And then like href is one of these attributes too. Like there's many different attributes, but for our purposes, we really also care about ID and class attributes. And ID and class attributes are used to identify either uniquely identify an element or to say an element is of a certain type. So for example, you could give an element a class button and then later use that reference to that class button to style it in a certain way so that it looks like a button. So here is like some boilerplate, and I'll give you more concrete examples of all of this in just a second if this is a little bit unfamiliar. Here is kind of like the absolute minimal legal HTML page that you could write. You have some kind of boilerplate. You have like a header information that usually contains information that is not rendered directly, but has stuff, for example, like what is up here in your browser tab and so on, but also like chart set encodings or language or anything like that. And then in the body, this is the part that you will actually see in the browser. And typically, HTML, as I already said, is structured hierarchically. And so here is a very simple HTML file that I'll be using for the first couple of examples. We can see I have a body element. In that body, I have an article. And so this article, there's like, this is the second level, and there's another article down here. And in that article, I have like a span, which is kind of like just a tag that I can use if I want to identify something. So the main purpose of the span here is that I'm giving it a class, and the class here is date. Then I have like the text inside the span is like when was this is about like albums, when was this albums published. Then I have a span class author and say Led Zeppelin. Then I have a H1. H1 stands for heading. So H1 to H6 or so are different levels of headings. And then I have my content. And here I say div. Div is just like another container element that's kind of like very frequently used, both div and span. I give it the class content. And in this case, I have some lyrics of that particular song in the content div here. And then similarly down here is like the same thing for Radiohead. So this looks very much like an object, right? So it's kind of like similar to when we saw objects that we created. We have different attributes that are assigned a variable, but it's kind of like a slightly different syntax using this HTML notation. But you can see that the title is always nested 3 levels from the top. I have body, article, and H1. And this file, by the way, is also included. So we can look at the, where is it? Here, the lyrics.html. And so this is what this actually looks like in the browser. So it's very, like, I didn't do any styling. I didn't do any markup. So it's not very pretty, but it's structured information. And it's kind of like a very simple example. OK. The other thing that you frequently encounter when you are working with HTML, especially for the purposes of data scraping, are tables. And so like in the exercise for today's class, there will be like a table about Olympic medal winners. And that's kind of like easy to work with, easier to work with than other structures. So, but just to introduce a little bit how a table looks like, you start out with like a global table tag, and then you have a TR tag that stands for table row, so that kind of indicates a single row. And then I have TH tag that indicates header cells. So I have like the first one here is empty, then I have the second one here is the Beatles, the third one here is Led Zeppelin. Then I end that row, then I start in the other row, and then my row kind of header here is number of band members, and then the Beatles have 4 and Led Zeppelin have 4. And so the number of columns here is implicit, kind of reconstructed based on how many elements you have. And this is what a table looks like. And like, yeah, as I said, tables are frequently like what data that you might want to scrape contain. And so it's useful to understand them. And I'll show you like a couple of tricks to parse tables very easily. So what we've seen so far are like markup documents that look like a tree. It has a root, it has an HTML elements. The elements can have children, and that they're containing elements with themselves. And HTML is kind of like this texture representation, but the DOM is the programming interface for it. And it's kind of like the dynamic representation, because as I already said, most websites are not actually written like this, right? They're actually generated in code, in JavaScript, querying databases, and so on. And so if we want to look though at what is going on with a website, we do want to be able to look at the DOM. And so here, this is kind of like the key feature in Chrome or in Firefox or in Safari. Every kind of like browser has developer tools. In Safari, you, for example, have to explicitly enable them somewhere in the settings. But in Chrome, you can inspect something. And then you get this representation here on the right that shows you the DOM and all of the elements in the DOM. And you can do that for every single website. Like the whole, like every website essentially publishes their source code, right? And so that's kind of like what we have to read and look at when we want to scrape something. And what's really elegant here is that I can click an element in the DOM, and it's highlighted in my browser, showing me where this element is. So it's kind of like easy for me to kind of navigate that. And even better, I can say, hey, what is like, this is the data field that I want. And I can say inspect here. And then it automatically scrolls to that particular field here. So I can see that span, if I wanted to extract the date, it's the date here is in the span of class date. It's nested in this article with ID radio. This is nested in the body, which is part of the HTML page. And so kind of like looking through the source code of a web page is how I actually go into scraping. And I can kind of like, you can see here is the content, and I can like navigate this dynamically. And of course, this website here is easy, so I can just like navigate here. But if you look at something more complex, you will quickly see that this is like a very long website, and you need to kind of like look at, like use mostly this technique of like right-clicking on the element that you care about, inspecting it, looking at what are the properties, how can I uniquely identify that element, and then extract it. Okay, so this is kind of like the most important technique for scraping, inspecting the DOM in a browser. And then once we have that, once we know what we want, we can scrape this data with Beautiful Soup. Beautiful Soup is a Python library that is designed for scraping, for computationally extracting data from HTML documents. It is like very established. It's been around for quite a while. It is widely used. It is very powerful. And I'm only going to give you a couple of glimpses in what you can do. Everything that you need to successfully work on your homework we'll cover today. But Beautiful Soup is much more powerful, and I'll later mention some more advanced scraping techniques that you might need for some new websites. So we'll use the simple examples with our Lyric HTML file. And like what I'm doing here is import Beautiful Soup. And I am like here with this command, Beautiful Soup open, with like the file that I'm looking for and telling it how to parse it. This is how I create an object. And so now the whole HTML file that I parsed is contained in this song soup object. And that song soup object, if I just print that or return that, It looks just like the HTML file, but it also has some other functions that I can use to retrieve stuff. But this looks exactly like the file that we fed into it. And sometimes like this is like a nicely formatted HTML file because I've actually written this by hand. But if HTML is generated, it can be very, very ugly. It can be like people also try to minify it, so to remove any spaces or like make variables super short if they include JavaScript. And you can do like you can kind of like make it a little bit prettier and layout it by using this prettify tag. So if I did that, you can see that like the indentation is a little bit different. Every level is indented a little bit, like one level more, which I didn't do in my HTML here. But that's useful generally if you wanted to sprint a particular section. OK, and so now we have in here, we have like in the header, we have a title tag, right? And so the first thing we want to do is we want to retrieve that title tag. And so if I do just songsoup.title, I get that particular tag. So that's easy. Now, this is something that I can actually like write to a variable, right? So I could store that in some way. But if I wanted to just have the content, I could do something like songsoup.title.string. And now I'm actually getting a string out of it. So this is now, I can actually store that in a variable or in a data frame or something like that, or convert it to a number if it were a number, and so on. When I try to directly access an element like this, it works for the first occurrence of a tag. So if I like do songsoup.div, we are getting the first occurrence. And so the first div in our HTML here is like this here. So we're getting exactly this leaves are falling div. And that's what we see here. We again can retrieve the content of an element by simply saying div.string. And so now I have kind of extracted the lyrics from that website. Or we can use attributes to find a specific element. And so this is where it really gets interesting. Like now I'm actually saying, take Beautiful Soup, run this find on all elements with the ID zap. And that will be only a single element because IDs are or should be contained only once on a website, though it's not always the case. And so now I can see that I have actually retrieved that article with the ID zap. And so in this way, kind of like I can create more complicated combinations. If I wanted to kind of like, there's a lot of text in here, including the published and the Led Zeppelin and the leaves are falling and so on. If this is good enough for me and I just wanted to get the text out of this, I could just say songsoup.find ID zap and then get the text out of it. And if I do that, I can see that I now have kind of like a textual representation of that HTML code that you've seen before. OK, so far so good. Find also only gives you a single element. If you're expecting multiple elements, so for example, like what the example will, or in this case here, we have like two songs and lyrics for those two songs or two titles. And so if we want to have a list of all the titles, we have to use find all. And I'm like looking at how could I identify the titles? It looks like the titles are in the H1 element. So maybe this is kind of like what I want to do. If I say songsoup.find all H1 elements, then I get back a list of all of the H1s. Like notice the list with the square brackets here. So I have Ramble On and Burn the Witch. So now I have those two title elements extracted. And we can, of course, like if you want to look at what is this, this is a list of Beautiful Soup elements. And if you wanted to get the text out of this, we can use just standard Python. So here, for example, I'm using like a list comprehension to extract the text out of it and kind of convert this into an array of two strings, right? And this is now, again, a familiar data type that we can do something else with. Find all, of course, also works with IDs. So I can say find all on ID zap. This works just as before. The only difference to before is that this returns an array. So if you're also expecting only a single element, you would have to do like array of 0 here. So this now would be equivalent to find of zap. And then you can do find all for classes. And classes are like usually very frequently used and useful to identify elements because they are like what we use in the background to style content. So if you want, for example, your headings of the titles to all look the same, they might have like a class title in here. And so I can find all classes by using the class underscore keyword here. Notice that it's class underscore, not just class, because class is a reserved keyword in Python. So there's the underscore in here. And if I do that, I retrieve both of these divs that have the class content in my array. And then I could use like a similar technique as above to extract the text, for example. And so find all is one way of querying and kind of extracting everything from an HTML page. It's so common. It's probably the most commonly used function in Beautiful Soup that there's this shorthand. You can just like, you don't even have to say find all. You can take just your soup object and use round brackets and say like, put in your query. And that is kind of is exactly the same as doing find all explicitly. I personally don't like that because it just is a kind of a weird, like, it's not very clear what you're doing. You have to know this convention. I think it's much better to do songsoup.findAll. But if you see code like this, know that this is equivalent to songsoup.findAll div. And again, we would have to access like this, the returned element from an array. And now we could do something like find all div and then iterate over it. And then in between, print this dashed line. And now we can see we have kind of like these two lyrics here printed next to each other. OK, so far so good. Any questions up to this point? OK, if not, now something that you like, if you've ever worked with HTML or ever heard of HTML, you've probably also heard of CSS. And CSS is kind of like the companion to HTML that makes stuff look like the way it is. So HTML is supposed to be the structure of a document, and CSS is supposed to define how it's layouted and rendered. And so this is kind of like a nice separation, content versus content and structure versus layout, because I can, for example, create like one content website with HTML, and then can use CSS to serve it up differently, whether I'm on a phone or whether I'm on a computer or whether it's night out, right? I could use a different color scheme. If it's night out, I like have a dark mode, and like many websites nowadays have a dark mode. And so CSS kind of allows us to separate the appearance from the content and the structure. And to the way that CSS styles stuff, like we're not going to look into styling, but the way it does it is by selecting on elements. And so similar to what we just did here with find all on an element or find all on a class, we have similar properties with CSS selectors. And so this would be like an example of what a CSS file would look like. Here we would have an article, like an article element, and we would say that article element should have the color firebrick, which is kind of a red. Then I have a my ID. This is like an element that has a specific ID, and I'm telling that element you're supposed to be tomato red. And the important part here is the element selector here does not have any, like this is just the name of the element. The ID selector has this hashtag at the top. So by hashtag, I'm telling the CSS selectors I'm looking for an ID. And then similarly for a class, I have a dot. So everything that starts with a dot matches to a class. And so these are the three main things. Like, is it an element? Is it an ID? Or is it a class? And that's kind of like a super kind of like succinct way of representing like these different properties here. And so now I could, well, I'll talk about this a little bit later. And then CSS can also do more advanced things. So for example, you can do, well, one thing that you can do, well, let me show this. You can do, let's say, a.myClass. So Now, this would apply only to elements that are of type A and of type myClass in CSS. And then I can do even more complicated compound selectors. So here I have a P, this is a paragraph element, and B is a bold element. And I can say, I want to select all of the bold elements that are directly nested within the P element. So that would be a paragraph that has directly a bold in it. That would match. So this is like this greater than size says this is a child selector. Only direct children here match. And then what's useful, very useful for scraping is the descendant selector. So if I do div B, I would match all of the bold elements that are nested inside a div at any level. So I could have div P and then something B, and that would retrieve that. So that would basically color all of the bold sections that are somehow nested within a div into the color green. So I can use this to style websites, but I can also use these selectors to work with Beautiful Soup. And this is actually my preferred way of working with Beautiful Soup, because this is such a succinct and efficient kind of way of accessing elements that it's very convenient to do that. So here, in Beautiful Soup, I simply, like, instead of find all, I run the select function. And the select function, I can then pass in exactly the syntax. And so select.content means select all of the classes that are called content. And so you can see that, like, by doing this on our simple example, I have retrieved those two divs that have class content. And similarly, I can select something in here with the descendant selector. So if I only want to retrieve the div inside of Radiohead, I could do it like this. I say element radio, and then at some level there has to be a div. And so, like, this sounds simple now, and it actually is simple, but it can be confusing if you have like a larger website where you have to parse it out. But this is kind of like what we'll be looking at in a more extensive example a little bit later. And this is exactly the kind of stuff that you'll also need to do in the homework. OK, so now the other thing is that up to this point, I've assumed that my website is locally on my computer, stored as an HTML file. But of course, that's not the case. Websites are on the web, right? That's why they're called websites. And so what we need to do before we work with it, we first have to download a website. And fetching a website is something that you can do. You can write a program that goes to a website and retrieves all of the code about it. Essentially, this is what browsers do. It is a little bit tricky in practice, because you can write, and like a search engine, for example, Google, the Google search engine writes what's called a spider that is traversing the web and accessing this all programmatically and then indexing the information. And we'll be doing something very similar to that. However, you can write a program, like websites are designed for humans, and you can write a program that just downloads like lots of data. And so a lot of people that build websites commercially don't want you to use programs to download their content, right? And so they explicitly say, you're not allowed to like scrape my website. And so before you scrape a website, you should, like, there's a couple of things that you need to be aware of. First, you should look at whether the website explicitly allows scraping or not. Many websites explicitly prohibit. So for example, Google Scholar is notorious for not letting people scrape it. And there's a couple of different ways of looking at that. Usually a website has terms of service. And so you should inspect the terms of service of a website and search for terms like scraping or crawling. They often say that you may not scrape the data, or you may scrape their data. For example, GitHub explicitly says that you may scrape their websites and download data from them. But Google Scholar, for example, says it does not. And the other thing to look at is this file that websites usually have that's called robots.txt. So if you go to scholar.google.com/robot.txt, you can see a little bit of information, like this is kind of computer readable, what is OK for you to do. So you're not allowed to reach into the search kind of subdirectory or URL. you're not allowed to go into the index. Kind of like, this is a little bit annoying because what you really want to do is you want to search in Google Scholar, right? So they don't want you to do that. You can do the, like, you can access this particular URL and you can access these particular URLs. Some websites also have kind of like rate limits because you can, if you can like request websites pretty fast on like if you write a program, and many websites they serve to many different people at the same time, right? So your ability to retrieve data from them is probably higher, especially if you have a good internet connection like on campus, than their ability to serve up data. And so they really want you to not try to download the data as fast as you can, but to kind of like maybe scrape once a second or once every 5 seconds. And so there's like this scroll delay of 30 seconds or 30 milliseconds, and the request rate at least at most once in 30 seconds. That's something that you frequently see. The other thing is that like it's nice, like these websites tell you that you're not supposed to scrape them, but they also, like, of course, if you just tell people, people will break the rules, right? And so usually Google Scholar or other websites will recognize that you are trying to scrape them, and they will like block you. And Google Scholar is really quick at blocking you. So if you try to like scrape Google Scholar, for example, you will immediately, after the third hit or so, you will actually see a CAPTCHA, which is some like one of these like human tasks that you have to follow. And if you do that CAPTCHA, you can continue. But of course, that kind of defeats the purpose of scraping. Or if you have an account, and if you were to try to scrape Twitter, they would just lock down your account, right? And then you suddenly couldn't access it anymore. So be careful. Really only scrape websites if they allow it. And I think if they don't explicitly disallow it, it's fair game to do it. But if they explicitly disallow it, then you should not scrape a website. And so we can fetch these websites dynamically from Python. An alternative to do that is to download a whole website with like a command line tool like wget, which if I scrape like a website, I usually first download the whole thing with wget and then work on my local copy of that website. And for your homework, we've also given you a local copy of the GitHub, of like a list of GitHub repositories, because the first year we used the homework like this, we asked people to scrape a server, and then the server recognized that like 100 students were trying to scrape their server and immediately shut us down. So that was a big mess. And so now we're like giving everybody local copies of the websites to scrape. Okay, so how, like, now I'll walk through this, how we do this. Yes, well, it wasn't denial of service, but it was, they recognized it, and then lots of students were blocked and couldn't complete the homework on time and so on. So it was a complicated situation. It was totally fine if just I did it or the TAs did it, but once we had lots of students do it, it was a problem. Okay, so what we'll do for like the example for the rest of the scraping part of the lecture is we will look at the University of Utah's class schedule. And so we'll extract the information. We can see that here we have like lots of different subjects, and you all are familiar with this, right? And if I click on computer science, we can see which classes are offered. And if we click on that particular class, we can also see how many students are enrolled in a class. And so what we want to create is we want to create a data set of like for a subject, list all of the classes, their instructors, and list how many students they have. And then we can do some analysis based on that information. OK, so first we need to download that website. And we will do this with the URL-lib request library. Here we specify the URL. This is this year's or this semester's course catalog. And then this is just the code for like requesting that URL. And then we save it to a file, because we will, like as I said, we're trying to be nice to the web server, and we will only download it once and store that file here in my HTML. And now I've also created my soup object, and that soup object now contains this this page. And so if we look at it, this is like a real website, right? And so you immediately see this is a lot more ugly than the simple website that I showed initially. So we have lots of meta information, lots of JavaScript and CSS being loaded here. And then here, like we start seeing some navigational items and so on. But this is kind of the stuff that we have to deal with if we want to extract information from that. But as I said, this is really like parsing this or reading this stuff here is really tricky. So you always want to look at what is going on in the browser. So if we look at this, and I'm going to do this live, if you look at this here, we inspect that element. So if you want to, like, first to get into a subject, what we want to do is we want to build like a dictionary of these subject shortcodes, and then the link to that subject's website. And so we can see that this here is stored in this div that has this ugly class call2-lg-2p1. So it has two classes. And then we have an A that has like a button, button light, button block. And then we have an href with the actual link. And that A tag, that link tag, has the information that we want. And so that's kind of like what we want. And so we can try, like, what is the information that is unique about this, and then try to extract it from there. So here is the relevant snippet. And like analyzing this, we can look at what are the unique elements that we can get for this. And so the way we do this is like here I am running soup.select on a button block. So this here is the one I'm doing. This returns, let's say, if I do this, I get an array back. I get an array back with all of these A elements, right? So for every class, like, it's not very readable here, but for every class, we can see we have for every subject, like aerospace studies, neurobiology and autonomy, and so on, we have one of these A elements. And so this is now what we are iterating over here. We're running, so it's saying for subject in soup select. Now we could, in here, we could print the subject, and this is going to look very much like what I have up here, like just this element. And this is now a little bit more readable, right? So now we've successfully identified the relevant part here. Now, what we want to do is we want to get the link out. So we can simply say subject.get the href element. That gives us the link tail here. As you can see, this is a relative link. And so I'm concatenating it with the overall URL that we have specified earlier. So this is just like the, where is it? Here's our URL. And so we're creating a compound URL out of this and this subdirectory that we are extracting here. And so if we do that, we can see here are links. Now we have like a list of these links extracted, and those links actually work. So if I click this, I go into this particular subject area. Next, I want to extract the text out of it. And so I'm simply saying here, subject get text. And then if I look at this here more closely, I see that they have this shortcode here, accounting, then a space, a dash, a space, and then the long name. And I want only the first part. And so I'm using a string split on this. Now I have my subject text in this array, and I'm using the first part here like as the key, subject text 0. This is like the accounting part, and the second part here, the accounting ACCTG part as my key in this dictionary, and then the second part here, the long text, as part of this tuple with the link that I have. And so what I get is like a dictionary like this. We have key CS, and then we have the full name of the field, and then we have the link to the particular field's class listing. Okay, so if we now run this, we get back this dictionary of all of the fields with their full name and their links. And so that's kind of like what we want to do. If we wanted to look at the entry for math, we can see math is mathematics, and it has that link. So that's exactly what we want. Notice that we could have taken a little bit of a different approach here. We could, like, if you look at these, we can see that the shortcode seems to be, like, in the URL, seems to be the same one as the shortcode in the text. So we could have also generated the URL by just using that shortcode. But then it is a little bit tricky because here, for example, we have a space in here. So maybe this, what we did, is actually the safer way, the more robust way. OK, so now we need to look at the course website. And the course website looks like this here. And the information we want is like the course number here, the title, who is the instructor, and then here, this link that gets us to this deeper, like this website one level deeper. And so if we inspect that, we can see that we have, this is kind of like in an H3 element. We can see that this is all part of like a class details div. So it looks like the whole website is, like, the whole relevant part for us is contained within this one div here. So if we scroll down, we can see that this is all part of it. So we actually can ignore the rest of the website and just retrieve that div and then extract these elements out of that div. OK, so let's do that. So here I'm like writing a little function that just retrieves that website and then converts that website into a soup. So I then run that website for computer science. And now what I have in this class soup object here is the soup for the particular entry. And if I printed that, I get my whole website. And as we know, this isn't very pretty. And we can look at this in the inspector much better. So this here is now for one particular class. This is the relevant piece here. I have like H3. This has the link that I want. It has the course number. It has the name. And well, the instructor information is a little bit further down. But like the H3 piece is what I want to start off with. OK, before I go into the details here, I'll take our 5-minute break now. I'll return at 1:12. Okay, so let's continue. So as I said, this is like a real website, and so it is quite messy. And so there's a lot of stuff that is in here that is like very brittle, but it's okay. This is like how web scraping works, right? You're not writing reusable code. You write code that works for the one time that you want to extract the data. So okay, what I'm doing here is like, well, first let's look at this again. I have inspected that particular element here. I can see that this is kind of like the name of the class here is contained within that H3 within that H3 element, and it's part of a link. And as I said, this whole thing is part of this class details ID and the card body class. And so here, this is kind of like this here returns a container that has more or less the whole piece here for every single class in that container as an item. And so now I can iterate over that. I can say for my course object, like this is the course here, corresponds roughly to like one of these blocks here for that in all of the classes. And if I do that, I can like show what the output here is of that. We can see that like we have that particular piece of the code here, which has the card body and so on. Okay, now the first thing we'll do is we will extract the course info from the H3 element, so this element here. And we simply say like we select H3, take the first element. This is kind of like the only element we'll get here. And then run get text on it. And if we print that, we can see our course info looks like this, right? So this is what we want. It's not nicely formatted, but this has the stuff that we want in it. Okay, then but of course, this here is split. Like we have the course number, the section number, and then we also have the title. So here we're doing some string manipulation. So I'm splitting by space dash. And I'm also taking only the first two elements because I don't want the section numbers. And I'm assigning that into my number and my name. And so if I do that, I can now, like, the name also has this, like, if we look closely at this, we have the 001, the section number here at the beginning. This is what this looks like. So we also don't want that. And I'm kind of like removing that with this particular piece here. And then string strip removes all of the white space. And so if I do all of those things, I get pretty clean numbers and names. So here I'm printing first the number and then the name. And so that looks great. The only thing is that this course is listed multiple times for all the different sections. And so we don't want that. And so to avoid that, we just have like one global set where we say the course number is kind of like unique. So here's my set that I initialized. If I already have that if I already covered that course, I'm just continuing and ignoring the rest of this and not storing that. But if this is the first time I'm seeing that course, I keep going. So now I'm writing the number into my into this set so that I can like later check for that. Okay, here we extract the URL. The URL here is in this part. So that part is like an A that is directly under an H3 element, and it's in the href attribute. And so this is what I'm doing here. I'm doing my concatenation again. And then for the course info, that is kind of contained in this unordered list here. So we have here, this is like the course info, like what I want is the instructor name. And I can see that the instructor name is down here. So that's kind of like a span inside a list element, inside a UL element, inside a div. And so what I'm doing here is I am selecting this UL-Li combination. And this contains all of the list info that I want. And then I'm just like working with this list. This has like a certain structure. I'm retrieving the first element, get the text out of it. We see that it has the element at index 1 is the second element. That's kind of an instructor, : Jensen, Peter. And I'm kind of getting that element, retrieving the text, splitting that, like I don't want the instructor part, but just want the person's name, and then retrieve the second part of that splitted array. And like I'm saying this now, this sounds like, well, sounds complicated, and it took me a while, right, to figure this out myself. This is like a trial and error, right? You keep printing, you keep working on this until you get the piece of information that you actually need. And so I keep doing this down here, like some more cleanup. I don't want to go too much into the details. This is more of an example for you to like refer to later, how you could do something like this. And then finally, I have all of the data. I have like the course number, the course name, the course instructor, the link. And then I'm also setting here an empty field for students. I'll tackle that later. I'll store all of this in a dictionary that I'm storing in the course rows array here. And after I've iterated over all of this, I can now create a data frame with that list of dictionaries. And if we look at this, we now have this nice and structured data set that has the course numbers, the course names, the instructor, the links, and we don't have the student numbers yet. So this will be our next step here. OK, so we can now use this already. We can ask who is the busiest instructor by simply looking at, do we have duplicate names in our list of instructors? And it looks like these two, Kem Yaxel and Jason Weesey here, both teach 3 courses each this semester. So it's a pretty busy semester for them. But the majority of CS people teach only 1 course. Great. So now next we want to look at counting enrollment. And I'm showing this because it's kind of like a great complement to what we just did, because what we just did is how, like, this is how most websites nowadays look, right? They have divs and spans, and this col and so on tells us this was generated, so this wasn't human written. But sometimes the data is much more like tame like this. And so here we have very structured information in a table. We'll see this is much easier to scrape. And so we'll retrieve this from the table. And the greatest part, like I could parse the table just the way I did here, but pandas actually can read HTML tables. And whenever you can do something with pandas, you should just do it with pandas because it's more powerful and does a lot of things for you, right? And so we will use pandas to read that table. The read HTML needs this particular HTML5 lib, which you might not have, but you probably have. But if you don't, you can run this command to get it. So here I am now retrieving like an example. I'm getting this for one of the classes. So let's look at this particular class here. This is 2420. This is it's actually the class I've opened here already. That's the intro algorithms and data structure class, which every CS major has to go through. That's kind of the pre-major class. So it's a very big class. As you can see, it has 385 students, enrollment cap. And so we will retrieve that class and put it into a soup. And then what we will simply do is we will try to read all we need to do now is to say pandas read HTML, convert this to a string, like take the class student soup out of it. And pandas will just look through that HTML and spit out a list of tables for every table it finds and load that into a data frame. And so I know that there's only 1 table on this website. And so I'm just taking the first one. And if I look at that data frame, I actually have successfully extracted that whole table already, right? So this is much easier than what we just did earlier. I have just basically this only single line here is all I have to do. And this is structured information. And so what I want is the currently enrolled students of the first row. And I can simply, the other rows here are just different sections, right? And so I just want to retrieve this particular number here. I can do that by accessing the currently enrolled column at row 0. 361 is what I want. And now I'm just packaging all of this into a function, the scrape students URL, scrape students with parameter URL. And then I'm running this for all of the courses. So here I have my courses data frame. I'm retrieving the link column as a series. I'm running apply that particular function up here. And then I'm setting the result of that into this new student series. And so if I run this, this actually now goes onto these web servers and retrieves those websites for all of the computer science courses. So this will take a little bit, but shouldn't be too long, less than 10 seconds, hopefully. Yep. And now we have our data frame. And here I'm just sorting it as descendingly by students. And we can see that the introduction to algorithms and data structure is actually the biggest class with 360 students. The second biggest is database systems and so on. And now we could do, like, we could analyze this class. We could ask questions such as, at which level are the most students enrolled in computer science? Like, is it 1,000 classes, 2,000 classes, and so on? This is like, this here is standard Python code that you've seen before. I'm just like demonstrating essentially, if we take that data and we want to do some analysis, here are two charts of that data set. We can see that there is not a lot of different classes at the 1,000 and 2,000 level in CS, but they are both fairly highly enrolled, or all of them are fairly highly enrolled. But then we see that there's many more classes at the 3,000 and 4,000 levels, but they are much smaller on average. And they're even much smaller on the 5,000 and 6,000 level. And you can see there's lots of 6,000 level. These are graduate classes. And there's even some 7,000 level classes in here with fairly low enrollment. And then if we look at the total number of students at each level, we can see that the most people are currently taking 3,000 level classes. And then 5,000 and 6,000 are fairly small, and 7,000, these are seminar and PhD level classes that are taken only by a very few students. Okay, that wraps up scraping. I just want to say this is very brittle. When I give this lecture every year, I have to change it because the website changes, right? Like websites like GitHub, or even the course website was completely revamped, so I had to redo the whole lecture and completely write it from scratch. That's okay, right? This is just what scraping is. You get the data set and you move on. If you want to reliably access the data set, it's much better to use an API. And then the other problem is that modern HTML is very different from what it used to be. And lots of websites actually dynamically generate the DOM. So for example, if you've been on Facebook or Twitter, you have infinite scrolling, right? You can keep scrolling and new data pops in. You can't just download a Twitter page, scrape a Twitter page, and expect 10,000 tweets to occur, right? What happens is that JavaScript listens to your browser scrolling, and once you've reached a certain point, it reloads and loads new tweets. And if you, for example, for your projects, have a website like this that dynamically loads new data or new rows, then you can't actually use Beautiful Soup. There's other tools like Selenium. Selenium is kind of like a browser automation tool that actually uses Chrome to access the website. Then you can actually do everything that you can do in a browser. So you could even scrape something like Twitter with a tool like Selenium, but I don't want to go into the details. If you need that for your project, there's like this tutorial, but the gist of it is very similar to what you've had before. You just look at the HTML, you identify what are the unique characteristics, classes, IDs, elements, and then extract that information.
I have a quick question.
Many services make their data available through some well-defined interfaces, which is called like an application programming interface. And using an API is always better than scraping because it's much easier, it's much more stable, APIs are versioned, and so on. And so this is what we'll move on to next. But any questions about scraping before we move on to APIs?
Yeah, is there a way that you can collect like the header response data from a page? Like in the network call, like the response data,
Okay.
Is there a way that you can directly reference that or pull that?
Let's see. Okay. So APIs are essentially like interfaces that you can get data out of that are hosted on somebody else's computer on the internet. Could also be your own computer. Sorry. I actually have my sound turned off, so I didn't hear anyone. Give me 1 second. Can you repeat the question now?
Yeah, I was just wondering, how would you go about scraping like the response header from a page? Like if you made a call in the network, how would you get like what the network responds with?
So you mean the response code?
Yeah, like how would you, yeah, like if I wanted to make the call on the web page and get that data set that it returns with, how can I do that?
Yeah, this is actually a good segue into this here. Like there is another parameter that you get from from any of those, like when I retrieve from the URL lib, the URL lib library will give you like a response back, and I'm just extracting this out of that. So you would just need to look at the URL lib request documentation. What are the response elements?
Okay, thank you.
Okay. Great. So now let's talk about APIs. APIs are these like well-defined interfaces, application programming interfaces. They're not necessarily made just for retrieving data, but they're really about interacting with a remote program on a server. So for example, you could write your own Twitter client, and lots of people do, right? You could write your like Apple or your iPhone Twitter client and put that onto the web store. And that's what these APIs are usually made for. Lots of the big services publish APIs. So for example, Stack Exchange or Twitter or Facebook or like the KEGG database, which is like a biological database, or Google Maps, all of them have APIs that you can work with. And from many of them, you can actually also get data that is interesting. And so you kind of retrieve, like these APIs also have some rules. And many of them actually require you to sign in or to have some kind of authentication, and they limit what you can do. So for example, Twitter doesn't let you download all tweets that were ever tweeted, right? It limits it. You can download at most 4,000 tweets per day, or you can pay for more access, right? So this is also a business model for many of those companies, making this data accessible to third-party users. So we can retrieve these elements in kind of like, and the response we get back is usually one of two ways. Well, there's REST APIs. These are kind of like the absolute dominant form nowadays. The REST stands for representational state transfer. And these use kind of like URIs. So this is basically a URL. But a special URL that has certain parameters and query things and so on. And so you put in that URL. For example, if I wanted to put in like a request for a certain tweet after I have authenticated, I could run this here, and I would get back tweets that kind of like match that query. The return values here can be mostly one of two forms. It's either the JSON format, which we've seen before, or XML format, and XML is more or less HTML, right? So these are very similar, but nowadays JSON is much more common, and so all of the APIs that you will be working with have most likely a JSON response until it's very old. And so we'll be assuming that we get a JSON response here, and we've worked with JSON before. This is JavaScript object notation. It's a pretty convenient format. And so what we'll do is we'll use like a simple, we'll be using a simple REST API that gives us some information about the International Space Station. And there's like this Open Notify website that has this API about the ISS. And I'm using the requests library that will handle our communication with the server. And so here is like this response code that I just got a question about. So here I've retrieved I've accessed that API, and I'm printing the response, and we see response 200 is the response code. So what do these different codes mean? 200 means everything is OK. You've probably seen the error 404. That's one of those response codes. 301 is like a redirect. 401, the server thinks you're not authenticated. 400, the server thinks you made a bad request. And 404, the resource you tried to access wasn't found on the server. So you've seen this before. And now, let's say if I were to submit an illegal URL that is not defined, I would get back like the server thinks you made a bad request. So my URL here didn't contain the right parameters. And what we are using here is a GET request. There's a couple of different types of requests. For data scraping, we really only care about the GET request. So I'll skip over this in the interest of time. We only have like 15 minutes left. But take a look at this. You can also like write to APIs with put and post methods, and you can delete from containers if you're allowed to. Let's look at the payload of the previous successful response. And so we see here, well, this looks very much like JSON. We see that it's actually a binary string. We can deal with that. But mostly it's JSON. We have a timestamp. We have a message that is success. And then we have the ISS's position, which is like a nested object with longitude and latitude. So if we want to like check what is the response type, we can actually ask content type. Oh, yes, it's actually JSON. We can say application.json. And then we can decode this byte object into UTF-8. This is like the character set. UTF-8 is nowadays a good bet, but back in the day, it used to be much more complicated. And now we have like an actual like string here that contains the response. And this looks like, as I said, very nice JSON. We can do something with this. And then we can import the JSON library to convert this JSON into objects. And so now I actually have an object that that we could work with. And of course, like pandas is great with data loading. So pandas can also read something, though like the format here isn't maybe all that useful, right? So here we have like latitude, longitude as rows, and then the timestamp and message. So we have to kind of like do something about this. So here I'm just like reformatting this so that I get kind of like a flattened response out of it, where I have latitude, longitude, and timestamp. So that's something that is useful. And now what I'm doing here is I'm now kind of like running, like retrieving the position of the ISS every 3 seconds, 10 times. So for 30 seconds, you will see stuff pop up here. And then we can see how fast or like how the ISS moves. And in here, like I'm just doing all of the stuff that I just described earlier, but just like in one big function with the flat response. And then I'm writing this into this ISS position array down here. OK, now we can convert this ISS position here into a data frame. We have like a timestamp. We have latitude and longitude. The timestamp is also the index here. And then if we wanted to, we can plot and see how the ISS moves. So that would be like a simple, like how I can get data from an API, move it into a data frame, and then do something with it. OK, we've like done so far, we've just consumed information without any query parameters, but we can also actually put in query parameters. And so here is like, and if you see a URL with like a question mark, everything that follows the question mark are query parameters. And so here I'm saying latitude, like ISS pass. This gives me, if we look at the documentation here, we can see that ISS pass. Yeah, this here describes what this particular function does. So it gives us a list of upcoming ISS passes for a particular location. And so we could use this function to actually query when will the ISS be over Salt Lake City the next time. And we do that by like putting in the coordinates of Salt Lake City, which is 40 and minus 111. You could just generate this URL yourself like this. You could just like use string concatenation to do that. But you also like the requests library takes a dictionary with parameters, and there you can have like your key value pairs, and that is then converted into the URL. And so that's a little bit more pleasant. And so if we run that query here with that URL, the ISS path, and these parameters here, we get back this data object. And so what we can see here, if we convert this to like a human readable time format, we can see that the ISS will next be over Salt Lake City on March 3rd at 8:19. Okay, so we could see, like, if you could spot the ISS tomorrow morning, if you had like a telescope or something like, well, in the morning it might be tricky to see, but anyways, you can look it up when the ISS will pass. Okay, so unfortunately, not a lot of APIs don't require authentication, so we will have to like create an account. For example, next I want to like analyze Twitter data, to do that, you will need to get an account on Twitter, and you will need to create an app, and then you will create special keys, and you then have to write these keys into this file here. Where is it? Credentials.py. Here you have like you'll get 2 of those keys. I've done this for my own information, but I haven't shared that file with you. So the rest of the code, if you don't have your own keys, is not going to work for you. But of course, I can't share that with you because you could like delete my tweets or tweet for me if you had those keys. And yeah, that's definitely not a good idea. So you never should share your keys, and you need to always make sure that you keep them safe. And the other thing is that what we've done here is the manual way. Like,
I have a question on that. On sharing the keys. The last homework assignment had a bonus question for Google Maps, but you're required to put in your key to get the maps. How would you do that without sharing your key?
So you can't. So in some APIs, you can generate a key for kind of like examples. Like Google Maps will always give you a watermarked thing if you use a public key, right? But also Google Maps is complaining about it. So you have to, like, you store the keys on a server that does that, but you can't put your key, you can't give them to somebody else, or you can't put them in a source code management repository. This is as good as your password, right? These keys, like if you have those keys, you can do anything that you can do with a password. So the other thing is that there's a lot of like Python and APIs is very common, and so there's like a lot of different libraries that make this working with APIs easier, that abstract some of the information. So where you have, for example, like a get tweet function in Python directly, and for popular APIs, somebody out there has certainly written this. For example, the Twython library that we'll be using here is an example of such a library that we can use to retrieve Twitter data very easily, much more easily than if we had to actually construct all of the API calls ourselves. So if you have a key, just put this into credentials.py and then change the code down here away from like here. I'm loading mine. You just need to load your own, and that's basically it. Okay, so if we retrieve a tweet, we get back a JSON object, and this is a tweet from President Biden's account. So here we can look at, this is like a pretty complex object, as you can see, right? So we have lots of different information. If we wanted to like look at the tweet, we can see we have the text of the tweet here. This afternoon, I'll be meeting virtually with Mexican president, and so on. And we have like a tweet ID. We have a timestamp. We have information about the user, like what's the name, it's President Biden, what's the screen name. Sometimes we have geolocation information in here, which is useful. We have the description, then we have like information to like their banner images and so on, their URL, more like plenty of information in here that we could use. We will later use the retweet count and the favorite count, like how often was this particular tweet retweeted, or how often was it favorited or liked. And so we can extract that information from the tweet. So like what I'm doing here is I'm importing Python. I'm loading this my credentials into this Twitter object that essentially now allows us to query Twitter. And so here we could say, like, I have a tag that I want to look for. like COVID-19, and I can say Twitter, search for the tag, and show me all of the extended tweets. And then I can look at the results. And now I'm getting all of these responses of what have people tweeted with that particular hashtag. And this isn't all that readable, so I can just retrieve the first one here, for example, and the text of that first one. Retrieving it here is like Greg evidence the statewide mask mandate, and so on. So we could now do this for all of the tweets and see what are people tweeting about COVID-19. And since we are in like a browser-based interface, we also nicely see like all the emoticons and so on. Okay, last couple of minutes, I will just run through like a brief example of how I could use this to like analyze the relative popularity of Joe Biden's official POTUS account and Alexandria Ocasio-Cortez, who is known to be very active on social media with lots of followers. Biden's personal account has more Twitter followers than AOC's, like 29 versus 12 million. But the POTUS account only has 8 million followers. But we are using the POTUS account here because the Biden account has been kind of like more or less hibernated and it's just retweeting POTUS tweets. And just as a point of comparison, Barack Obama has 130 million Twitter followers and Justin Bieber has 114 million Twitter followers. So this is like a sizable number, but they're not the biggest people on Twitter. We can search for every mention of a particular account like this. The query is @JoeBiden. So these are people mentioning Joe Biden in tweets. Or we can actually retrieve the tweets from a particular person. And so here I'm retrieving all of the tweets of Screen Them POTUS, or all of the tweets, the last 50 tweets. There's like a limit. You can at most do 200 per request, and you can access at most 3,200 tweets of a user. So if we do that, we get back all of the tweets that Biden recently made. And now we could extract, just by like accessing the right elements, the favorite count and the retweet count. And so look at this a little bit more closely. Here is it printed out? We have the tweet and these counts. And then we can do the same for Alexandria Ocasio-Cortez. Retrieve her recent tweets, extract these favorites, the retweets, and the text. And then we can create a data frame for both of them and then explore their stats a little bit. And we can see that like here we have like Biden, this tweet here has been favorited about 50,000 times and retweeted about 6,000 times. We can look at the, like use the standard stuff we do in Python. Like on average, these 50 tweets have been retweeted 55,000 times, favorited 55,000 times, and so on. And then we can look at what are the most popular tweets. We can see that this tweet here, not many people have Oval Office walk-in privileges, has been like most favorited. And we could look at what are the least popular tweets. Retweets, they don't get favorites counted like this. And then here are some tweets that are like have only 10,000 favorites. We can do the same thing for AOC and then combine both of them and then analyze those together. So we can see here we have the AOC favorites. Seems like for the most of her most popular tweets, Alexandria Ocasio-Cortez actually has more favorites than Biden for his most popular tweets. But on average, it looks like Biden gets more favorites. So she seems to have a couple of zingers that people like, but on average, Biden gets favorited more. And for retweets, it's like a similar picture. There's a little bit noise here because I can only sort by either favorites or retweets. But yeah, you can see information like this here. And you can now basically extract information from Twitter if you want to do that for your project. Which kind of brings me to the end of today's lecture. There is an exercise. We won't have time, so I'll not open up a group today. But if you want to like do the exercise, you're welcome to submit it into any of the activity bins on Canvas. I'm happy to take any more questions if there's some.
In one of the examples, the API, you set like a timer to request it.
Yes.
Is there similar, like if I wanted to like do like a webhook from like an API source, would it be just how the API formats that, or is there like a specific way to deal with like waiting for a call from an API?
There's like here I just used some of the built-in Python sleep thing. So here I'm saying simply time.sleep for 3 seconds, so my program holds and then continues after 3 seconds. Here I really did it mostly because I wanted to give the ISS some time to move, right? But yeah, that's a good way of, like, if you have some time limits for scraping, you could do it like this. Some of the
that's for
libraries
like
might build in a timer.
Sorry. That's because that's like a timer. But what about if we're waiting like on an event happening in the API? So, say for the ISS one, we're waiting for the ISS to get to a certain point and then have it get it at that point.
No, you could do that. I don't know whether it's actually passive, right? Like you have to run this on your computer. You can't really retrieve information. Like they can't send you stuff.
Okay,
It's
just
like
through
the
the Jupyter notebooks. It has to be like on a server of some kind, or
yeah, and even then, like I doubt that a lot of like Twitter, for example, has a streaming API that you can listen to, but I don't think well, I'm sure they have like a method to notify you, but it's probably still a pull thing. So in practice, this is really like for retrieving data, that's probably not going to work most of the time.
Okay.
Like on a website, you would if you wanted to do this on a website, you would have to have something like a WebSocket connection to a web server so that the server can notify you. This is like how you get notifications on Facebook. But that's kind of advanced stuff, and you need to run a server.
Okay.
But yeah, WebSocket would be an option to do something like this, but I doubt that a lot of APIs support that.
Okay. Well, thank you.
Sure. Okay, well, if there's no other questions, I'm looking forward to talking to all of you on Thursday. On Thursday, I'll also briefly talk about the projects, give a bit of an overview of that. Goodbye.